In this chapter calendar, we are going to see the concept of odd days and how to identify whether a given year is leap year or ordinary year, and thereby we can find the day for any given date. Now let us see how to find. Before that, let us see some concepts. January, as all of you know, it will be of 31 days. February, it will be of two kinds, 28 and 29 days. And from March onwards, 31, 30, alternately they will come. And July and August continuously 31. Once again, that alternates 30, 31, 30, 31, it continues. February is of two kinds. One comprising of 28 days, that is ordinary year. And 29 days, it will be of leap year. Now, identification of leap and ordinary year. How to find whether a given year is leap year or ordinary year? Any year, say 1956, if it is divisible by 4, then it is leap year. Now, check for any number, it is not necessary to divide the entire number by 4. The last two digits are sufficient whether it is divisible by 4 or not. Now 56, yes, of course, it is divisible by 4. Sharply we are getting 14. So it is leap year. Suppose on the other hand, 1950. 50 is not divisible by 4. So it is ordinary year. So this is the way to check. Check the last two digits are divisible by 4 or not. If it is divisible by 4, it is leap year, otherwise it is ordinary year. Now, what about the century years? Of course, 100, 200, all hundreds are divisible by 4, no doubt, but they are not leap year. Only 400 and its multiples, that means 400, 800, 1200, only these alone. That means the multiples of 400 alone leap years, and the rest of the century years are ordinary. So the divisibility test by 4 is not applicable for century years. Once again I am telling, for non-century years you need to check whether it is divisible by 4, the last two digits. If it is divisible by 4, it is leap, otherwise ordinary. In case of century years, although all the hundreds, 200s, multiples of hundreds are divisible by 4, but they are not leap. Only 400, 800, 1200, the multiples of 400 alone leap year. The rest of the century years are ordinary years. Okay, now the concept of odd days. What does it mean? Any number of days are given. Complete the subtract completely means subtract the weeks. The days left out is called the odd days. Now let us see. 30 days. Now in this 4 weeks are there, 4 sevens are 28, plus 2 days are there. These 2 days is called odd days. Now say 15 days. Now 2 weeks are there, 2 sevens are 14, and 1 day is left out. This one is called the odd day. Now say 35 days. Now it is completely 5 weeks, and nothing is left out, 0 odd day. So the days are given, so split it into 2 parts, the weeks plus the remaining days. The remaining days left out is called the odd days. Now in case of ordinary year, we know it comprising of 365 days, so 52 weeks plus 1 day is left out. So for an ordinary year, the odd days is 1. On the other hand, the leap year comprising of 366 days, accordingly 2 days are left out. Let us summarize. So ordinary year means 1 odd, leap means 2 odd. And this 400 and its multiples, it is a special category. It is, for them, it is 0 odd. While framing the calendar, they themselves fixed. It is assumption, we cannot do. So 400 and 800, this is one separate category. For them, the number of odd days is 0. Okay, now we are tabulating the all months. Earlier we have seen 31, 30 like this. Now we are tabulating in terms of odd days. 31, of course, 4 weeks, so 3 days are left out. For 30, 4 weeks, 4 sevens are 28, 2 days are left out. So now we don't want 30, 31. We want in terms of odd days. January 3, March 3, once again it will be alternately 2, 3, 2, 3 will come. And in case of July and August continuously 3, once again the alternate starts 2, 3, 2, 3. And for February, 0 odd, because 28, 4 weeks are there, nothing is left out. So for ordinary year 0 odd, and for leap 1. So we don't want the previous one 30, 31. We want the tabulation of months in terms of odd days we are going to use during the calculation. Now odd days for 100 years and its multiple. Now 100 years duration they have taken, and they found, after subtracting the complete weeks, they found 5 days. Similarly, 200 years means for every 100 you have to take 2, and 5 days. For 200 years, 2 5s are 10. But in 10 days, again 1 week is there. After removing this, we have 3 odd. 300 years, 3 5s are 15 days. But 2 weeks are there, 1 day is left out, 1. Fun, I already told 400 and its multiple, it will become 0. From now onwards, anything, suppose we want to find 3500 years, what is the odd days? Simply split this into 2 terms. One, that is 1 multiple of 400s. Nearest multiple of 400 is, it is 3200 plus 300. I am splitting this into 2 parts. One in terms of the multiples of 400, the another remaining hundreds. As I already told, multiples of 400, the odd days are 0. So 300 means for every 100, 5 days. So for 300, 3 5s are 15. So again 2 weeks are there, I removed them, and 1 day is left out. So for any, see I am telling, say 1700 years. How the nearest multiple of 400 is 1600 plus 100. And I told the multiples of 400, it is 0 odd, and for 100, 5. So it is 5, 0 plus 5, 5 odd days. If some weeks are there inside, we can remove it. So this is the way to find the number of odd days for the century years. That means 100 and its multiple. So it is very easy. Once again, I am telling, for 105, 210, 315, and thereafter simply subtract weeks if any. And for 400, it will become 0. Now let us see the odd days for the year which are not multiples of 100. Say, suppose I want to find the odd days for 85 years. Simply divide by 4. Now 21 leap years are there. 21 leap years are there. So out of 85, 21, so remaining 64 years are ordinary. Now, why we are dividing by 4 this number represent? Because the every 4th year is a leap year. So if 85 years means as many 4s as the number of leap years it will give. So divide by 4, you are getting 21. Out of 85, 21 are leap. So remaining 64 are ordinary. As we already seen, every leap year has 2 odd days, and ordinary year has 1. So 21 leap years. So it will be 21 into 2, 42 days, plus ordinary year 1 odd day. So 64 ordinary years will have 64 days. Now how many weeks? 6 weeks are there. 6 7s are 42. Nothing is left out. And 64, 9 7s are 63. 9 weeks are there. 1 day is left out. 0 plus 1, 1 odd. Now let us find one more. Say I want to find 46 years. The odd days for 46 years. Now what I told, 46 divided by 4. that is 11 leap. Out of 46, 11 are leap years, so remaining 35 are ordinary. Remaining 35 are ordinary. So as every leap year has 2 odd, so 11 leap years will have 22 days plus 35, it will be 35 days only. Now subtract the weeks. So 3 weeks are 21, so remaining 1 day. Here sharply 5 weeks are 35, nothing is left out. So 0, 1 plus 0, 1 odd. Once again I am telling you, divide the number by 4, you will get a number that represents leap year and the remaining will be ordinary. Double the leap and ordinary as it is. Thereafter, simply subtract the weeks, you will get the odd days. This is the way to find the number of odd days for non-century years. Okay. What is the relation between odd days and day? At the final, if you get 0, the day is Sunday. And this is the order 0, 1, 2, 3, 4, 5, 6 is there. That side, the day is Sunday, say Monday, in order it will be. Now, let us see how to find the day for any given date. Suppose we want to find what was the day on 15th August 1947. Okay, now reduce 1 from the given year, that means 1946. Why? 1947th year only 15th August only, incomplete year. 1946 complete years are there. Now the nearest multiple of 400 is 1600 and remaining 300s are there plus 46. As I already told, the 400 and its multiple have 0 odd, and for every 100 we have to take 5. 300, 3 5s are 15 plus this area we have to divide by 4. Now if we divide by 4, we are getting 11 leap and the remaining 35 are ordinary. And once again bring this 0, no need, 15 plus 11 leap. So as every leap year has 2 odd days, so 11 leap 22 days plus 35 ordinary equal to 35 odd days. Now subtract the weeks. Here 2 weeks, so 1 day is left out. Here 3 weeks, again 1 day is left out. Here 35, 5 weeks are there, nothing is left out. So we have got 2 odd. Set aside. This is for this 1946, 2 odd days. Now we have to find out for 1947 till August 15th. Now let us see. 1947. We have to check. Now it is January, February, March, April, May, June, July, August. August we have to find out up to 15, and 1947 is ordinary year. So February, the odd days is 0. 28 days. So now January 3 odd, March 3, 2, 3, 2, once again July, and August only up to 15th, not for the entire August. So 15, 2 weeks are there, 1 day is left out. You just add all these things. Now 3, 6, 8, 11, 13, 16, 17. So 17 days are there. So after subtracting 2 weeks, we have 3 odd days are there. So this is for 1947 till August 15. This is for 1946 full years. So finally this 2 plus 3. Now 2 plus 3 equal to 5 odd, and we have seen from the table 5 represents Friday. So once again I am telling you, so any date, suppose 1947, reduce 1 from the given year and write that into 3 parts. 1, the multiples of 400 and the remaining hundreds if any, plus the remaining number. And multiples of 400s, they have 0 odd days, and for every 100, 3, so 300, 3 5s are 15, and this we have to divide by 4, which will give you the leap, and the remaining will be ordinary. Leap should be doubled, so it has become 22, here 15, here 35 as it is. Now subtract the weeks, write down the remaining numbers. We have got 2 odd in this area. Now 1947, we have to go for up to this August 15. So I have written the odd days corresponding to them, and 17 days we have got. Again, after subtracting the weeks, we found 3 days are odd. Now we have to sum up these two. And finally, we got 5 odd, 5 represents Friday. This is the way to find the number of this thing. Now let us see one more we'll take. 25th July 1988. Reduce 1 from the given year, 1987. Nearest multiple of 400, it is 1600 plus remaining 300, and then 187 is there. As multiples of 400 have 0 odd days, and for every 105, so 300 will become 15. Here this part we will divide by 4. 87 by 4, that is 21 leap plus remaining 66 ordinary. So bring this 15. This leap will become double, so it will become 42 plus 66 will be as it is. Now 15, so after subtracting 2 weeks, 1 day will be there, and 42, 6 weeks are there, nothing is left out. Again 66, 9 weeks are there, so 3 days are left out, so the number is 4 odd. This is for 1987. Now 1988, we have to go up to July. Now let us see. 1988. January, February, March, April, May, June, July 25. Now what about this? 1988 is a leap year. So February will have 1 odd. Here January 3, March onwards 3, 2, 3, 2, July 25. There are 3 weeks, so 4 days are left out. So after adding all this, 7, 9, 12, 12 plus 6, 18. So 18 means after subtracting the weeks, we have got 4 odd. Now if we sum up these two, 4 plus 4, that is 8. Now 8 means 1 week, so 1 day will be left out, 1 odd. As from the table, 1 represents Monday. So you have to be very careful. Here only the mistake will arise. This February will be 1 or 0. That depends upon this year. If it is leap, then it will be 1. Ordinary means it will become 0. Here only the chances for wrong can occur. Now today is Monday. What will be the day after 30 days? It's very easy. 30 days. 30 days means the number of odd days. After subtracting 4 weeks, 2 days are there, 2 odd. So today is Monday means we have to go 2 days ahead. 2 days ahead means Tuesday and Wednesday. So any number of years or any number of days, just find out the odd days. Go that many days ahead. You will get the new day for it. This is the way. Now, yes, how to find 25th July 1988 was Monday. What was the day on the same 25th July in 1995? That means the date, the day and month remain same. Simply some 10 years ago or 10 years after. How to find? Now, first see, write down 1988 to 95. Now, one thing you have to keep it in mind, here January 1 to February 28, it comes under left hand side, and February 29 to December 31st, that is right. Now our question, our date lies on left or right. Now 25th July, it comes on right side. So we have to take the right end and avoid the left end. If the date falls on left side, then take the left end, avoid the right end. Okay, now we need to find here which years are ordinary or leap. It is very difficult. Find out one leap year in this. Yes, of course, this is leap year, I think. 92 is divisible by 4, it is leap. Automatically, once leap means 3 consecutively ordinary will be there. So no need to check every time. All you need to check is only the leap year. Thereafter, you keep on writing 3 odds on leap like this, either front or back. Now ordinary means we know 1 odd and leap means 2 odd. So total we have 6. 6 plus 2, 8 days are there. 8 days means after subtracting 1 week, we have 1 odd. Now 1988 is given, 1995 they asked. So we need to go 1 day ahead. See here Monday. So 1 day ahead means that day is Tuesday. Suppose here it is Monday is given. We have to find this 1 day, you have to come back. That's same. So all you need to find out is this day lies on left or right. If it lies on left, take left hand side, avoid the right hand side. And if it lies on the right, take the right hand and avoid the left. And after calculating, you'll get this thing. If you want that side, you go ahead, 1 ahead. If it is, we want the left side, the prior one, you have to come back. This is the way to find. One more problem of this kind we'll see. 4th February 1995 was Saturday. The same 4th February they were asked. 2002 they asked the day. As I have told, see, this 4th February till February 28, January 1 to till 28th February lies on the left hand side. So we need to take the left hand side. We have to avoid the right. Now we have to find out one leap year. 2000 is leap. So we have to find out 0, 0, 0. That means ordinary. And this is leap. Again this side ordinary. Here 1995 we need to take, because this end 1995 it is also ordinary. So 1, here 2, 1, 1, 1, here 1, 2, again here 1. The total is 5, 6, 7, 2, 9. So 9 days we have. Now 9 days means after subtraction of 1 week we have 2. That means 2 odd. So already the date is Saturday. So 2 days ahead, we need to go 2 days ahead. So Saturday, 2 days if we ahead means Sunday, it is Monday. So that is very important. If the date lies on the left, take the left hand, avoid the right hand. If the day lies on the right hand, so take the right hand and avoid the left. Thereafter, calculate the leap and the total, that many days you need to go ahead. Now, find out how the calendar for the years are the same. Suppose we want to find for the year 2003, which calendar of which of the following years is the same. Now we know 2003 is ordinary year. So in the option you go for only ordinary years only. Here 2012 being a leap year, no need to check, because ordinary year calendar will match only with ordinary year and the leap year calendar will match only with leap year. So this question the 2003 being ordinary year, no need to check for leap years. So let us check 2003, what is the odd days. 2003 means nearest multiple of 400 is 2000 plus 3. The odd days for multiples of 400 is 0 and 3 being ordinary, so it will be 3, so 3 odd. So 2003 has 3 odd. Now we need to check in the options for which the 3 odd, there only the calendar matches. Now let us see for 2013. 2013, 2000 plus 13. Now this will become 0. Here we need to divide by 4. So 3 4s are 12. So there will be 3 leap, and out of 13, 3 leap means 10 ordinary. So leap we need to double. So 3 2s are 6. Again ordinary will be as it is 16. 16 after subtracting the 2 weeks, we have 2 odd. So we don't want, we want the answer to be 3 odd. Now let us check for 2014. So again 2000 plus 14. For multiples of 400, 0. So 2000 will become 0. Here divide by 4. So 3 4s are 12. So 3 leap, remaining 11 are ordinary. So leap should be doubled. So 6 days plus here 11 ordinary will be 11. So 17 days. So after subtracting the weeks, 3 odd are there. So the 2014 and 2003, which is mentioned in the question, both have the same odd days, 3. So the calendar, both the years are ordinary years also and their odd days also equal. So the calendar of 2003 will be the same as the calendar of 2014. This is the way to check.